So we're now going to move on to our next sponsored keynote speaker, David Mohr from Neo4j. David is an experienced entrepreneurial and hands-on leader, and we are deeply looking forward to his talk, Innovating with Graphs. So, David.
Hey, good morning, everybody. I'm Dave Mohr with Neo4j. I'm actually based here in Boston. It's a beautiful day here. Really nice to finally have a beauty and to be in an event. It's been a couple of years for me, so probably for everybody else as well. So I know I've got 15 minutes. I'm going to go through really what it is about graph that makes it really interesting and something to pay attention to. We do have a table up in the vendor area, so happy to answer questions up there as well, depending on how the timing goes here. So the presentation is going to start with really what are the forces driving the need for graph technology. There's a ton of technologies out there. Why do I got to use graph? What's driving the need? What are the forces at work? Why do I actually have to do something? Why should I do something different than I've been doing forever? Then succeeding in the age of connected data. And then how to get started. So really kind of keeping it simple, three kind of major areas, and we'll get started. So what are the major forces out there? We're all in the data world, and data is growing every day, exponentially. You've got variety, you've got velocity, you got volume, you've got data. There's this cliche out there that data is the new gold. So leveraging your data would seem to be something that could help you drive business value and create opportunities. You've got people, processes, assets that if you can find the connections and the relationships between those processes, there's, again, opportunity for value. And that's where graph really plays. It's in driving business value. So we call that the connected data imperative. So finding those connections and those relationships, exposing those, is going to help you get business value. There was a study done by McKinsey, and I think they did a version 2.0 of this back a few years ago, around succeeding in the age of analytics, and this should be publicly available. You can get access to that. So the connected data imperative, to drill down on this a little bit more, it's not that you just have the data, but it's the relationships between the data that are really key. It's not just raw data that's interesting. It's how does that data relate to each other so that you can, again, access the business value that's hidden in that data. So some of those areas would be networks of people where you've got employees, you've got customers, you've got suppliers, you've got partners. I mean, today's world, the supply chain issue is really creating a huge problem for the entire world. You've got shortage of products, you've got shortage of transportations. So understanding all of those relationships and being able to optimize that. You can start to save money, you can optimize your supply chain, and that's just an example. Transaction network, so look at how risk management is done, or the payment processes where you've got digital payment streams going on every day by millions and millions of transactions. So there's a lot of connected information flowing between banks and consumers and products. All of that is all data. It's all digital. And then knowledge networks, so knowledge graphs, being able to make sure that the right content or the right domain-specific information is getting to the right person, supporting your e-commerce platform. So knowledge networks are examples of the need for connected data. And then the real major force that's going on is digital transformation. So this rounds out the three forces where you've got really companies are building out their businesses changing based on the need to become digitized. So you've got your the old bricks and mortar, you've got pure digital cloud first kinds of companies, and some of those traditional brick and mortar organizations are transforming their business to become more digital oriented. Gobs of data is being created as a result of how their traditional business is being morphed into supporting the digital world. So they're forced to do something with that data that the old way still don't work to support what they're trying to do. So some of the use cases that we see in these organizations are data-driven discovery, so drug discovery, crime detection, product and process innovations. Then there's the personalization aspect, so finding those relationships and connections in the data allows you to address your end consumer or your business partners more effectively and efficiently to what their needs are. Helping you with decision-making, business intelligence, data warehousing, using that data more effectively will help you make better business decisions. Then there's large amounts of data integration, trying to get a 360-degree view of anything. So you need to consolidate, pull the data together to get a 360-degree view of your customer. Well, that information is sitting in silos of SAPs and data warehouses and other transactional systems. You need to be able to pull that together and find the connections in that data very quickly. And then there's the whole AI and machine learning with data science. So now you're applying algorithms to your data. I think the last speaker talked about statistical process. Using more statistical methodologies to look at that data is another opportunity given digital transformation force at work. So moving forward, how do we succeed in the age of connected data? So again, getting back to why do I need to do something? Why can't the old ways work? So the Gartner Group, Rita Salam, I don't know if she's here today, put out a report a few years ago that by 2025, graph technologies are going to be used in 80% of data and analytics innovations. That's pretty powerful. 80% of analytics are going to use graph technologies today. Just by a show of hands, anybody using graph technology today? So I put that at about 5% of this room, maybe 8% of this room. So to see the opportunity that your analytics are going to require or use graph, there's a lot of upside for graph technology in the marketplace just by showing this room. So to quote them, finding relationships in combinations of diverse data using graph techniques at scale will form the foundation of modern data and analytics. That's a pretty powerful prognostication, I think. Very powerful. I understand this one might be a little bit of an eye chart, but this is coming from DB Engines. And on the left-hand side, you'll see a bunch of lines. I know it's probably hard to read, but these are the different database types of technologies that are in the market today that are available. The bottom line is relational database. That red one is relational. The green one that's going up and to the left is graph. So this is going back to 2013. I don't know if that doesn't work, but right around 2016 is where you see that little inflection point where graph is really starting to separate itself from all the other types of database technologies over there. Coincidentally, I joined Neo4j in 2016. I just had my 6-year anniversary yesterday. I'm not taking credit for any of that. Like I said, it's purely coincidental. But I do see a broad adoption of Neo4j and graph in general in the marketplace. On the right-hand side, you can see there's a pretty robust graph vendor marketplace going on. Neo4j, is at the top. We pretty much started the graph marketplace back in 2012 2009 is when I think we got our first round, but the company started building the software in 2000. So it's actually been around for quite a bit. And so this is showing the popularity and trends in the graph database market. And you can get this, just go to DB Engines, and it's a third-party website. So how do you unlock value from your data using those connections? And this is kind of like a prescriptive approach, right? This is, how do I do this? What's the best way to go about doing it? First, you need to be able to store those data relationships natively. And everybody's familiar with LinkedIn, and LinkedIn is all about the relationship, if you will. It's a really good analogy for a social graph. You can pull up a person, their profile, and you can see what connections you have in common with them. That's because all that data is stored as a graph. What companies those people work in, what companies have you worked with in common. All of that is stored natively. You don't, as a user of that, you don't have to query for that, and that's really powerful. That's where those relationships are exposed. They're hidden, they're buried in the data, but they're exposed because it's already stored natively. You got to think about your data as a graph. It's a big mind change, going from what everybody's most familiar with would be tables or spreadsheets. It's a big mind change to think of your data as a graph, basically nodes and relationships. Using that relationship information in real time helps you transform your business. And as an example, a recommendation system where you've got 360-degree view of your customer, and you understand what they're looking for, what you have in your inventory, what kind of promotions you might be running, and being able to deliver them a personalized recommendation in real time is going to probably make them buy something more likely than not. The other thing is that because we're in this digital transformation world, there's new data that's being created in other systems across different channels all the time, and you want the flexibility and the agility to be able to incorporate that data into the systems that you're using. So again, how do you unlock value? Being able to check the boxes on these bullet points. That's an example of a graph. So you can see that Dan is married to Ann. He lives with Ann. Ann owns the car, but Dan drives the car. So you can see, you can really model your real-world situation really flexibly in a graph data model. Trying to do that with relational or traditional databases, it's really hard to do. And then trying to be able to incorporate new data and new types of information in there it's pretty difficult to do. So Graph supports transactional and analytic workloads. So again, the next step you need to do is really look at an enterprise-grade graph database technology, not just open source or something that's somebody's throwing together. So you need a database that's really designed for the enterprise and for commercial purposes in order to really get business value out of it. So that database should store, reveal, and be able to query those relationships, traverse and analyze the data. So if you're looking at relational databases and you're trying to get data that might be 20 or 30 different hops away, it's pretty cumbersome. So you want to be able to traverse, and if you use the LinkedIn analogy, how you can just bounce around through profiles and connections really quickly. That's how you're able to navigate the graph real quick. And then be able to add context and new data to support these machine learning and AI applications. So Graph is supporting both transactional workloads like recommendation systems, as well as analytic workloads where you're looking to find trends in that data. So I've kind of alluded to this. Why don't relational databases handle data relationships really well? Well, first of all, they don't store the relationship. So those, you have to design a schema that has keys and across tables. And when you're trying to do that across many tables or trying to add new data, it's pretty cumbersome to do. The queries themselves are going to be very complicated. You can see on the right, there's some pretty complex SQL code that's required to be able to do all those joins and relate all that data. The query complexity grows, the join logic grows. It's a lot of code that has to be developed. So relational databases are not very good, ironically, because relation is in their name. They're not very good at relationships because they're just not dynamic. They have to be predefined, essentially. What about NoSQL databases? You heard all about the schema-free, just bring it all in. Well, they're not that great. They don't handle relationships at all. So we're talking about the native relationship. They don't handle that. And as a result, they don't have the data structures to store those relationships. They don't have the query construct to leverage those relationships. Relating data between them requires join logic. Again, more code that you have to build and then maintain. A lot of times they don't support ACID-based transactions, so they'll only be good for the analytics side or searching, not necessarily for transactional kinds of applications. So NoSQL isn't the answer only. So where are some of the high business value use cases? Here's really just kind of a high level of some of the categories: real-time recommendation, fraud detection, network and IT operations, MDM, knowledge graphs, identity access management. And here's just a smidgen of some of the customers. We pretty much focus on the, we've been focused on the enterprises that are $1 billion and above. So we're using their logos, but I can't get into the details of their stories because their applications are very important, very strategic, and we're under serious confidentiality agreements with them around this. So what we do have out on our website are some public stories that we can share, but 95% of them we can't share. But here's some examples of graph at work. AstraZeneca is a big customer, and we're across most of the pharmaceutical companies and biotechs. Here, their challenge was identifying trends and similarities in kidney patients, and having billions and billions of records and all types of data points, office visits, and various kinds of data coming in from around the patient. And they're looking for better ways to improve patient outcomes for kidney patients. How much time do I have?
You're overtime.
Overtime. Okay, so I'm going to blow through this. My last slide is how do I get started with graph? There's many ways to learn. It's really your choice. You can get hands on the software. You can play in the sandbox. We have online and public education. Most of it is free. You can read some of the books. We publish many of those, review many of the videos, work with our huge ecosystem of third parties, work with the Neo4j team. First step for you is to think about your data differently, reimagine your data as a graph, because they're everywhere, and everything starts to look very graphy. That's it, and stop by and see us at the vendor roundtable upstairs.